this? What is this? This is 1 minus r times 1 plus r squared plus r to n minus 1. Okay? And a more general one is this one. A to the n minus b to the n is a minus b times a to the n minus 1 plus a to the n minus 2 times b plus a to the n minus 3 times b squared, and so on. A to the n minus times a, and then b to the n minus 2, and then I will finish plus b to the n minus 1. Okay, so this times this. Those from algebra and do the factorization. Okay, so therefore, so from here, therefore 1 plus r squared all the way to r to the n minus 1, this guy, is equal to 1 minus r to the n divided by 1 minus r. Okay, this you just multiply it out, you will see that this equal to this. Okay, so therefore, so from here, right? So Sn, which is 1 plus 1 half plus 1 half 1 over 2 squared plus 1 over 2 to the n minus 1. This is exactly 1 plus 1 half plus 1 half squared plus 1 half to the n minus 1. And therefore, if I use this rule, this is 1 minus 1 half, okay? And then 1 minus 1 half to the nth power. So this guy. And I can simplify this. This is just 1 half. 1 minus 1 half to the n. Okay? And so this is the same as 2 times 1 minus 1 half to the n. Okay, same as this guy. Alright, now remember the definition. The definition says that if the limit, if this limit exists, if this limit exists, then the limit is the sum of this. Okay? So right now I want to know if the limit of this exists when n goes to infinity. So see if you can see it here. Alright, so I'm taking the limit Sn, right? When n goes to infinity. This is 2 times 1 minus 1 half to the n. When n goes to infinity, this goes to 0 because 1 half is less than 1. If I take more power of it, it's getting smaller. So when n goes to infinity, this guy, and the limit, this guy drop out. So this equal to 2. So I know that. Therefore, this series is convergent. Is convergent to 2. The sum of this series is 2 because the limit of this is equal to 2. Alright, now let us go back to the problem before, like this man versus turtle problem, and let's see why this argument looks true, but yet in real life it's wrong. Okay? Alright, so I'm going back to this main turtle here, okay? So okay, so suppose I'm this distance here, okay? So say from here to here I need 1 unit of time. Then so from here, if I walk half is 1 half of time, 1 half unit of the time, whatever that unit is. Okay, maybe 1 hour, maybe 1 minute, or maybe half an hour as 1 unit, whatever. So suppose I need 1 unit to go from here to here. Okay, 1 unit to go from here. Then when I walk half unit, halfway, okay, halfway, I use 1 half of the time, right? 1 half unit of the time to walk half of this. Of course, the turtle walk a little bit, but normally it's very slow, so it's really not very significant. Okay. Now, next, when I walk another half of this, so that time is about, well, now it's half of the half, so it's a quarter of the time. Then when I walk another half of a turtle is already walking a little bit. But normally, keep in mind, turtle is very slow, so this is very, very insignificant. But then I spend 1/8 of the time. So if I keep doing this, so how much time does the person spend? In catching the turtle, okay? Alright, so let's see, alright? 1 half, right? Plus a quarter, right? Plus 1/8, right? And so on, keep going down, right? Keep doing. But keep in mind, turtle, although it's very slow, but it's moving. It's really moving, okay? So, okay, but let's continue. So in general, okay, 1 half, this is A1, this is A2, A3, right? So A times this one. So this is the time. This is really the time that I spend in catching up this turtle. So how much time did I actually spend, okay? So I'm going to adding this up, right? Using the formula I have before, I'm going to factor this 1 half out. So I have 1 plus 1 half. Okay, I just make it mathematically simple. This 1 half is 1 plus 1 half plus 1/4, right? So I put 1 half out. And so this is equal to what? So it's 1 half, 1 plus 1 half plus 1/2 squared, right? But this one we just did a moment ago. This was equal to 2. This is equal to 2. We just did it a moment ago. We compute, right? Remember we compute this. 1 plus 1 half plus 1/2 squared plus 1/1. We compute this one is 2. So, what? Of course, I can never catch it because remember the setting. From here to here, I need 1 unit of time. So, when I spend 1 unit of time going all the way here, the turtle is already, no matter how slow it is, it has some distance here. So in other words, for all this time that I spend, I actually only go from here to the original position of the turtle. So So I never catch the turtle because the turtle is already ahead, even if it's only say 1 meter. I still didn't catch it. That's the idea of this infinite, that you can never catch it. Okay. So I use turtle, but in the old time they probably use arrow, shooting a bird or something like with arrow. The argument is you can never shoot a bird if you look at it shooting, you never catch it. The idea is this one. I mean, when you reach half of it, it's already moved away a little bit. Okay. Anyway, so this is the idea that why this concept is very important, because the concept is really how do you add up infinite many terms? The sum of infinite many numbers is not infinite. That's the idea. Okay? Alright. So let us look at some exercise problem here. Keep in mind I did one thing here. So okay, so I did one thing here, right here. Here. I did one thing here. So I'm going to write this as a theory, okay? As a theory. So here's, I'm going to write it as a theory. If I'm adding up infinite many terms, this will be equal to, let me do this, equal to 1 over 1 minus r, if r is less than 1. Okay, the reason is that why? Why is this true? Well, this is because if I add up that nth partial sum, okay, n terms from 1, starting with 1, n terms will be equal to r to the n minus 1. And this is, we did it right, is 1 to the 1 minus r. So limit as n when n equal to infinity, this will be but because r is smaller than 1, so this r to the n drop to 0. So this is 1 over 1 minus r. This is what I wrote down here. Okay? And this is only true if n is 1 is less than 1. Okay? Alright, so 2. Likewise, I just multiply everything by a number a. So a plus, if I have a plus ar plus ar squared, ar to the n, this will be a over 1 minus r. If here, absolute r must be less than 1. Okay. And this one is given in fact, this is given in the book. This is called theory 8.7, geometric series. So I'm going to call the name, okay? This is theory 8.7 on the book. It's called geometric series. And this is on page 621. Okay. All right. So let us work some problems, and this is really what you need to know is this whole thing for this section 8.3. Okay. So let us let me look at some exercise here. Okay. So the numbers here are 7 to 39 and 55 to 67. Okay, the problems on this section. So why don't we start looking at some problems